Unit 25, solving for other angles. You guys, I'm going to skip through this reading part, and I'm going to go on to the next page, and we'll kind of talk about the things that were in the reading. So on the next page, we have a sample problem. It says to solve for center to center and end-to-end lengths of threaded pipes J, K, and L. Back in 1B, we spent a lot of time solving for end-to-ends using threaded, PVC, and copper. We are going to continue doing that, but we are going to change up the degree of the fittings in this unit. So the first thing we're going to do, I'm going to zoom in here to our figure. Okay, we have an 1.5-inch threaded pipe. You need to remember that when you are dealing with threaded pipe, after you've subtracted your takeoff, you have to add your thread size back on. Otherwise, you will have the wrong size for your end-to-end. So, first of all, we have the answers over here on the right-hand side, but we're going to figure out how to actually find these answers. Now, remember, a lot of times this book is not the greatest and has incorrect answers, so we will find out if they are correct or not. So let's first start out by finding the end-to-end for J. If we look at J, here is pipe J. And they tell us that pipe J is 13 inches long from center to center. So over here in the table, they have 13 inches. Now, to find the end-to-end, we're going to have to do a little math here. So we are going to, in the back of our books, go to table 5, I believe. On table 5, it is on page 264. We are going to use a 90-degree fitting, and we also have a 60-degree fitting. So, to start out, we have 13 inches, and we are subtracting off. In the table, I am going to 1.5 inches, 90 degrees, and I am finding 1 15/16. 1 15/16 minus 60 degrees does not fall in data table 5. We're going to have to jump over to data table 6. On data table 6, we go to 1.5, 60 degrees threaded. And it looks like it is 1 3/4. Plus, we have to add back our threads. 1/2 inch on one fitting, 1/2 inch on the other fitting. And we are trying to find what this equals. Hopefully you guys all have your construction calculator. That helps with fractions a lot. I'm going to pause and plug all of this into my calculator and see if I get the correct answer that the book has. Alright, so I plugged into my calculator and I did get 10 5/16. Hooray, the book was correct. Okay, that is end-to-end for J. Now let's move on to pipe K. So you guys, up until now, we have been focusing a lot on finding diagonals where our fittings for the diagonal were 45s. I know most of you work with 45s in your everyday careers a lot, meaning if you know the rise or the run, or your setback or your offset, you would times by 1.414 to get your diagonal. We are going to do something very similar, except for we are not going to times by the constant 1.414, because we do not have 45-degree angles. Okay, you should notice that we are using 60-degree angles. So when we have 60-degree angles, one thing that's super helpful is if you go to table number 26. Okay, table number 26 has all of the constants that you'll be using. So right now I just flipped to table 26. And if I look at the 45-degree angles, I will see the 1.414. But we want the 60-degree angle. So on the 60-degree angle, the constants are 1.155 and 0.577. Those are the constants we're going to have to use. So, first things first. If you notice down here, it tells us that our run or our offset is 21 inches. So I'm actually going to bring that up so that I remember that this right here is also 21 inches. And this is called our offset. So, looking again at data table 26, it says that if you want to find your diagonal, and it's a 60-degree angle, you are going to multiply by 1.155. So, to find my diagonal, I am supposed to take my offset, which is 21, and I'm supposed to times it by the constant, 1.155. Now, that is similar to the 1.414, but we are using 1.155 because we have a 60-degree angle. After plugging that into my calculator, I am getting 24.255. I'm going to convert that really quickly to a fraction. An easy way to convert back to fractions, you have a data table in your appendix in the back of the book. It's data table number 1, and that will tell you what your fractions are. And so this is equal to 24.25 inches. So if you notice there, 24.25 inches is exactly what the book has for the center to center of K. And now we need to find the end-to-end measurement. So we have 24, use the actual pen, 24.25, and we need to subtract off. Well, first let's look at our fittings. It looks like we have a 60-degree fitting and a 60-degree fitting. So we would go to data table number 6. We go to 1.5 inches threaded, and that is 1 3/4. So we have to take off 1 3/4 inches from each fitting, plus we have to add back our threads on each fitting, which is a 1/2 inch on each. So if I do the calculations for this, we have 12.25. We're subtracting off 1 3/4. We're subtracting off another 1 3/4, and we're adding back on 1 inch. When I plug all of that in, I am ending up with what the book got, 21 3/4 inches for end to end. So far the book has done okay. The last thing that we need to find is the end-to-end for pipe L. So what we're going to have to do in this situation, we're going to have to use some of our mental math skills. Now, we know, if you look over here, that the entire rise is 39 inches. Our goal is to figure out what L is. L is right over here. So to get to L, what we're going to do, we've got to take our 39 inches. We are going to have to subtract off 13 inches. And we also need to subtract off this length right here. So 39, subtract off 13, subtract off whatever this length is right here. And whatever's left will tell us the center to center of pipe L. So to figure out this length right here, you are going to use the data table 26 like we did before, but this time instead of solving for the diagonal, we are solving for the setback. Okay, this is called your setback. So what we're going to do, data table 26, it says to take your offset, multiply it by 0.577 because it's a 60-degree angle. Okay, I'm going to write this down. To find your setback, you are going to take your offset, which is 21 inches, and the constant you are multiplying by is 0.577, and that's going to equal, let's see, 21 multiplied by 0.577 is about 12.117. And 12.117, if I convert that to a fraction, is 3/16. So 12 and 3/16. So you guys, that means that this measurement right here is 12 and 3/16. So again, what we need to do, we are taking the entire rise, which is right here, 39 inches, and we are subtracting off the measure of pipe J, 13 inches, and we are subtracting off the setback, which we just found, 12 and 3/16. And whatever's left over is going to be the center to center of L. Hey, you guys, as I was looking, when I converted our setback decimal to a fraction right here, this actually is not 12 and 3/16. It is 12 and 1/8. I looked at the book too quickly. So right here, instead of having 3/16, we need to edit that and make this 12 and 1/8. Which means that this right here should also be 12 and 1/8. Sorry about that. I just got going too fast and didn't realize I looked at the wrong row. Okay, so now, if we plug into our calculator, we are trying to find center to center of L. We need to do 39, subtract 13, subtract 12 and 1/8. When we do this, I am getting 13 and 7/8 for my center to center of L. Now that we know center to center of L, we're able to take it one step further. Our final goal is to find the end-to-end measurement. So what we need to do, we have 13 and 7/8. We need to do our takeoffs. So we look up and we see, okay, L has a 60-degree and a 90-degree fitting. So for the 60-degree fitting, I go to data table number 6, 1.5 inch threaded pipe, and it says the takeoff is 1 3/4. Minus, we have a 90-degree fitting, which comes from data table 5. 1.5 inches would be 1 15/16. Plus, we have to add back our threads on each end. And now our job is to do the math and see if we come up with the same answer as the book. As I plug this in, I am coming up with 11 3/16 inches end to end for pipe L. Scroll back up. Hooray! All of our answers match what the book did. That will not always be the case. Unfortunately, the book has some errors, so our job is to find them. Okay? This is the end of Unit 25.